All right, let's jump right in. We all know AI models are getting bigger and smarter, but here's the catch. Making them specialize for new things is, well, it's incredibly expensive. So today, we're going to break down a really clever new technique called DiffLoRA that tries to solve this exact problem: how to get that top-tier performance without the crazy high cost.
And this really is the core problem, you know? The large language models we use every day are absolutely amazing, but they are enormous. Trying to fully retrain one for a specific task, for most companies, it's just not possible. It's too expensive, takes too much time. And this has kicked off a huge race to find smarter, more efficient ways to tune them.
So, here's our game plan. First, we'll dig into what we're calling the AI training dilemma. Then, we'll look at the two key ideas that led to the main innovation here: DiffLoRA itself. After that, we'll get into the fascinating and, trust me, very mixed results of their experiment. And finally, we'll unpack what it all means for the future of AI.
Okay, so let's start with that big dilemma. When we talk about adapting these massive AI models, what exactly makes it so difficult? Why can't we just teach them new things easily?
Well, it really just comes down to sheer scale. These models have billions of internal parameters. You can think of them like tiny little adjustment knobs inside the AI's brain. To change all of them, what we call full fine-tuning, requires a truly staggering amount of computing power. This whole problem has created an entire field of research called parameter-efficient fine-tuning, or PEFT for short, which is all about finding these clever shortcuts.
Now, the researchers behind DiffLoRA, they didn't just start from scratch. Their work is a brilliant combination of two powerful ideas that were already out there. So let's break those down first.
So, on one side, you've got LoRA. LoRA is all about efficiency. It's a way to make these small, surgical updates to a model instead of doing a total overhaul. And on the other side, you have differential attention. This one is all about performance. It's a way to help the model focus on what's important and just ignore the noise.
You know, the core idea behind LoRA is just brilliantly simple. Imagine an AI model is like a massive textbook. Instead of rewriting the entire book to add new information, LoRA is kind of like adding a few super smart sticky notes. You only have to train what's on those notes, which, as you can guess, is dramatically faster and cheaper.
Differential attention, or DiffAtten, tackles things from a different angle: performance. Models can get really distracted by irrelevant data, things called attention sinks. So think of DiffAtten as a pair of noise-canceling headphones for the AI. It literally helps the model subtract the background noise and focus on what truly matters. The only catch? It usually has to be built into the model right from the very beginning.
And this, right here, brings us to the main event. What happens when you try to smash these two powerful ideas together?
This is the huge question the researchers were asking. Could they get that amazing focus and performance boost you see with differential attention, but achieve it with the speed and efficiency of LoRA? In other words, could they teach an old AI a brand new trick?
And there you have it. This is the core innovation. They fused these two concepts together, hoping to create a brand new method, DiffLoRA, that could get the performance of a deep architectural change, but with the efficiency of a super lightweight adapter.
So the crucial idea here is that DiffLoRA uses those efficient sticky note adapters to teach a pre-trained model a whole new skill, that noise-canceling ability from differential attention. The goal was simple: get that powerful performance gain, but without the crippling cost of a full retrain.
An elegant idea is one thing, right? But the real test is always performance. And this is where the story gets really, really interesting, because the results were not at all what you might expect.
First, the massive win. On a benchmark called HumanEval, which is all about testing an AI's ability to write code, DiffLoRA didn't just beat standard LoRA, it completely blew it away. We're talking a huge 11-point improvement. This suggests that for certain complex structured tasks, this noise-canceling approach is incredibly effective.
But then, you get this. On other tasks, specifically ones that involve searching through documents for answers, a technique called RAG, the model sometimes just completely broke down. Instead of giving a useful response, it would get stuck in this repetitive loop, producing what the researchers called degenerate output. It's a pretty stark contrast to its success in coding, right?
This table really sums up the split verdict perfectly. DiffLoRA was the clear winner on those structured tasks like coding and retrieving specific facts, but on the more open-ended tasks that required reasoning over text, like Q&A and in-context learning, the simpler, standard LoRA was actually much, much better.
And it's worth noting, just for context, that all of these experiments use the Llama 3.21b instruct model as their foundation. So these results really show how each technique modified that specific baseline.
So what do we make of all this? A result that's both a stunning success and a pretty significant failure isn't a dead end. Actually, in research, it's a huge opportunity to learn something fundamental about how these incredibly complex systems really work.
And this is the million-dollar question, isn't it? What was happening under the hood that could possibly explain this dramatic split in performance? Well, to find out, the researchers took a look inside the model's brain.
So these charts, they basically reveal what was happening inside the AI. The purple bars you see on the left, that's the attention pattern for standard LoRA. Now look at the green and yellow for DiffLoRA. The yellow part shows the noise that's being subtracted, so okay, it is working. But look at the main green pattern. It's almost identical to the purple one. DiffLoRA wasn't really teaching the model a whole new way to pay attention. It was just kind of cleaning up the edges of the old way.
This all led the researchers to a key hypothesis. Maybe those efficient little sticky notes just aren't powerful enough to overwrite a model's deeply ingrained training. Teaching an AI a fundamentally new way to think, rather than just new facts, might require a much stronger signal, or maybe just vastly more training data than they used. And this leaves us with a fascinating fundamental question for the entire field of AI. When we want to change not just what a model knows, but how it thinks, are these small, efficient updates really enough? Or do some skills run so deep that the only way to learn them is to go back to school and start all over again, right from scratch?